Yeah guys, welcome back. So today we'll be looking at 2009 May-June past paper question 9A. Alright? And so what we're doing guys, we're solving simultaneous equations with one linear and one non-linear, which is exactly what we have there guys. Alright? So when you look at equation 1, you see firstly that it is definitely linear because it takes the general form y equal mx plus c. Alright? And then you look at equation 2, you see that it's definitely a quadratic. So guys, let's get straight into it now. So basically guys, when you look at the two equations, you see that they're both y's, that is y is equal to. And so what we're going to do, given that is the situation, we're going to equate them. That is, we're going to put them equal to each other, yeah? Alright, so here we go. So 2x squared, we put in equation 2 equal to equation 1, so that is 2x squared minus 3x plus 1 is equal to 4 minus 2x. Alright guys, our next step is to transpose. That is, we're going to carry everything over from the right hand side to the left. Everything. Alright, so here we go guys. So we have 2x squared minus 3x plus 2x plus 1 minus 4, and that is equal to 0 guys. Alright, so the next step after that guys is to simplify the equation. Alright, we have a few like terms there, so let's go ahead and do that. So we have 2x squared minus x minus 3, and that there is equal to 0. So now what we have guys is a quadratic equation, and so now we are required to solve that quadratic equation in order to get the values of x. So our chosen method is to factorize it. Of course you could use the quadratic formula, but we're going to factorize it. Alright, so here we go guys, and if it is that you don't know how to factorize, then check our video on factorization. Yeah, so we have 2 multiplied by negative 3, and that is equal to negative 6. That is our step 1. Step 2, what two numbers multiply to give us negative 6 but at the same time add to give us negative 1? So that is negative 3 multiplied by 2, that is going to give us the negative 6, but at the same time negative 3 plus 2 is equal to negative 1. Our step number 3 now requires us to rewrite the equation, and the equation now is 2x squared minus 3x plus 2x minus 3, and that is equal to 0. Remember, we have to maintain the fact that it's an equation. Step number 4 is to factorize. Alright, so we're going to bust it down the middle, and we're going to pull out the highest common factor. And the highest common factor there guys is x. So we're pulling out the x, and inside the bracket we have what? 2x minus 3. Alright, we don't know what's going to be in the second bracket. That's pretty much the same thing as the first, 2x minus 3. Alright, now in front of the bracket guys, you don't know what we have there. It's a plus 1. Why is it a plus 1? Because 1 times 2x is going to give us back that 2x, and 1 times negative 3 is going to give us back that negative 3 right there. Alright, so don't forget again guys, put it equal to 0. Yeah, alright. Our step number 5 guys, step number 5 is to write our two binomials, that is x plus 1 and 2x minus 3, and that is equal to 0. In our step number 6, we're going to solve the two binomials, that is x plus 1 is equal to 0, and 2x minus 3 is equal to 0 also. Good. So x is equal to 0. We're going to carry over or transpose the positive 1, so it's going to become negative 1. So our value of x is negative 1. That is our first value of x. our second value of x, 2x minus 3 is equal to 0. I'll rewrite that again. Alright, so what we're going to do, we're going to transpose the negative 3, and that's going to give us 2x is equal to 3. We're dividing both sides by 2 so we can get that x by itself. Alright, good. So now we have the value of x is equal to 3 over 2. And it's that simple, guys. So far we have our values of x. So x is equal to -1 and x is equal to 3 over 2, or 1.5. Yeah? Okay, so our next step, guys, is to get the y values. How are we going to get the y values? Alright, so let's just scroll back up just a little bit. Alright, just a little bit there. And we're going to find our y values. Now remember, x is equal to -1 and x is also equal to 3 over 2, or as we said, 1.5. So how are we going to get the y values, guys? We're going to substitute each x coordinate into the easiest equation, that is going to be the linear. Now of course you could plug it into the quadratic, but we're going for the easier route, yeah? So guys, equation 1 is exactly what we're going to plug those coordinates in. All right, so equation 1 is y equal 4 minus 2x. Okay, so what we're doing, guys, we're going to substitute x equals -1 into equation 1, which is that equation. So wherever we see x, we're going to replace it with -1. So here we go, guys. Y is equal to 4 minus 2 times -1. All right, 4 plus 2 is equal to 6. So yeah, guys, y is equal to 6. Now when x is -1, y is 6, and that's what we're talking about, guys. When x is -1, y is 6. So that there will definitely be our first point. All right, when x is -1, y is 6. Of course, we're not finished. We are not finished because we have another x value that we need to substitute. So let's go ahead and do that. We're going to substitute x equals 3 over 2 into the same equation 1, which is y equals 4 minus 2x. All right, so wherever we see x, we're going to replace it with 3 over 2. So that is y is equal to 4 minus 2 times 3 over 2. All right, so what we have here, guys, is 4 minus 3, and y is therefore equal to 4 minus 3 is 1. All right, guys, so now we have our y value that corresponds to x. Yeah, so that is when x is 3 over 2, then y is 1. All right, and so that is our answer, guys. Those are our answers. Yeah, so we have y is 6, y is 1, and we also have x is -1, and x is also 3 over 2. All right, so those are the answers, guys. We just solved the pair of simultaneous equations where one of them is linear and the other one is non-linear, and the non-linear one, based on what we're seeing, is quadratic. If you're having difficulty with factorization, please go and see our next video, guys, or our video on factorization. All right, now I did go through the steps, but you don't know. Check it out now.